Look at this. On the left, we have a simply supported beam. On the right, we have a simply supported frame. The load is same, the span is same, even the supports are pinned. So most people expect the behavior to be the same. This is wrong. The moment a beam becomes a frame, bending moment appears at the joint, even under gravity load. And if you don't understand this, you don't understand how real structures behave. Today we'll see exactly why a beam and a frame respond differently under the same load. Let us start by modeling a simply supported beam. Span of the beam is 12 meters. Let us assign some properties to this beam. Let us assign pinned supports. Let us assign a loading of 4.5 kN per meter. So this is a simply supported beam 12 meter in span with a UDL of 4.5 kN per meter. Let us model a similar beam with the only difference of fixed support instead of pinned support. Now these are two beams. One beam is simply supported and another beam is fixed support. The span is same, the loading is same. Let us understand the difference between these pinned support and fixed support conditions. Let us consider these axes. Horizontal is your x-axis, vertical is your y-axis. In simply support condition, translation is restrained and rotation is free. In the case of fixed support condition, delta x, delta y and theta all are restrained. You will get this kind of deflection in pinned support connection. In fixed support condition, deflection is different. Here rotation is not allowed towards the support and theta is equal to 0. This is the reason in pinned support connection, moment at supports is 0, but in fixed support condition, moment develop at supports. Let us see this in STAAD Pro. Now before analyzing this in STAAD Pro, we need to change certain parameters. As this is a 2D model, we need to mention in command file that we are working on a 2D model. Let's give the command of analysis. Now let's run the model. Let's go in post processing and check the results. As seen, the deflection of simply supported beam is in this way where you have free rotation towards the support. But in fixed support condition, towards the support you do not have any rotation and the deflection is different. Let's compare shear force diagram. Shear force diagram in both the cases will be same. Also the values will be similar. Now let's compare bending moment diagram. The bending moment diagram for simply supported beam is as seen over here. Towards the support the bending moment is 0. But in fixed support you have negative bending moment at the supports. Let us see the values. You have a maximum moment of 81 kN meter for a pin supported beam and you have a maximum moment of 27 kN meter for a fixed support beam at the center. Now for the same example, we will just convert this beam into a frame and see the results. Let's remove the supports of the frame. Let's check the loadings. Let's check the dimensions. Now we can see these four structures. We have two beams at the top. Same span, same loading, but one is pin supported and other is fixed support. At the bottom we have two more structures, a frame, 8 meter in height, 12 meter in span. One is pin supported and other is fixed support. Let's assign material to this frame. Now we have same material, same span, same loading. Let's analyze this and check the behavior. Here we can see deflections of beam with pin connection and fixed support, and at the bottom we can see deflections of frame with pinned support and fixed support. The connection between column and beam is a rigid connection. Now let's check forces in the beams. These are the shear forces in the beams. Let's check the values. We have shear force of 27 kN in our beams. Same shear force is there for the beams in case of frames. But now the columns have also developed some shear force. Let us check the axial force. In beams we do not have any axial force. But now in frames we have certain axial force developed. Whatever is the shear force in the beam, that shear force gets transferred to the columns in the form of axial force. Let's check the values. We had a shear force of 27 kN. That same shear force is now transferred to the columns. All the columns now have a 27 kN of axial force. There is also certain axial force developed in the beams of the frames. Bending moment for the simply support beam at the center is maximum, and bending moment for a fixed support beam at the center is minimum. Now let's see the same case with the frames. You can see at the column beam junction there is redistribution of moment. In case of a pinned support frame, the moment at the support is zero. But in case of a fixed support frame, you have certain moment developed at the supports. Let's check the values. You can see the maximum bending moment developed at the center of the beam in case of a simply support beam is 81, and you have 27 kN of bending moment developed for the beam which is fixed supported. Now in cases of frame, you can see the frame which is pin supported has some bending moment which is 43 kN. Same bending moment in case of a fixed support beam is reduced to 40. So for a fixed supported beam, the moment is reduced, but it is not as less as in case of a beam. In beams we have a bending moment of 27 kN, but in case of frame we have a moment of 40 kN. In this way we can see a difference between a beam and a frame behavior. Let us compare the deflections. You can see the displacement in a beam where rotation is allowed. You have maximum displacement for a pin support beam. Comparing it with a fixed support beam, you have minimum displacement because at the supports rotation is not allowed. Now let's compare the frames. Between column and beam junction, you have a rigid support. In pin support condition, rotation is allowed, that's why this kind of deflection is visible. But in fixed support frame, rotation is not allowed, that's why a different kind of deflection is visible. Let's check the values. You can see maximum deflection in case of a simply support beam and minimum deflection in case of a fixed support beam. When comparing it to a frame has slightly less deflection compared to a beam. Comparing two frames, a pin supported frame and a fixed support frame. A fixed support frame has slightly less deflection compared to a pin support frame. So in this way, we saw overall behavior of two beams and two frames, one pin connected and other fixed. So remember this clearly, the load did not change, the beam did not change, only the structural system changed. A beam is an isolated element, a frame is a connected system. and once elements are connected, they must rotate and deform together. That compatibility is what creates bending moment in frames. If you understand this difference, you will stop guessing structural behavior and start predicting it. This is real structural engineering.